Choosing quadrats at random in the plot. Let's imagine that our plot of Tundra is a giant 20 meter by 20 meter bingo card. Wow! On a real bingo card, each column is identified by a letter B, I, N, G, O. But on our plot, there are 20 columns, so we will need to use numbers. It will be easier that way. We know that scientists always place the numbers at the bottom of the grid, aligned to the lines rather than the columns like on a bingo card. On a Cartesian plane, the numbers at the bottom form the x-axis. They are simply called x's. But to be able to place quadrats anywhere within the plot, we will also need numbers on the y-axis. Now our plot really starts to look like a Cartesian plane. By combining any x column with any y row, we can position ourselves anywhere in the plot. Since there are 20x and 20y in a plot, we obtain a total of 400 meeting points between the x columns and the y rows. Therefore, there are 400 xy coordinates. Before going on the plot to pick berries, we need to randomly select 50 xy points from among the 400 possibilities. Each point will become the location of a picking quadrat. When we get to the plot to pick the berries, we'll need to find at least 25 quadrats that contain berries. But there's no way in knowing in advance how many quadrats will actually contain berries. This is why, before going on the field, we will select many more locations than the 25 we need. In fact, we'll randomly select 50 quadrat locations. That way, we'll be sure to have at least 25 with berries. How are we going to randomly select the x column and the y row for each quadrat? Very simple. First, we'll choose an x at random. Then we'll choose a y at random. One random x plus one random y, well, that makes one random quadrat location. Easy. Of course, it's super to shut your eyes and use your finger to select randomly. But it is never as much fun as using the dice technique. Here's a die with 6 sides. This die enables us to choose an x from 1 to 6. No, it doesn't work. That's no good because we need 20 x's. Of course, with this one, we can choose an x between 1 and 20 because it's a die with 20 sides. So it has a side for each possible x. Here you go. And with a blue die with 20 sides, I can easily choose a y from the y-axis. Now it's easy. With my orange die and my blue die, I can easily get a pair of xy coordinates to randomly select the location of my quadrat. With this technique, each team will be able to randomly select the coordinates for the quadrats. Each pair of xy coordinates will correspond to a specific quadrat location. If a team lands on a quadrat location that has already been drawn, then the dice are simply rolled again. When 50 quadrat locations have been chosen at random, we'll draw up a list. And we will also make an identification label for each quadrat. Obviously, we'll have to wait to be in the field before we can fill in the section state of the quadrat on the label, since we can't know in advance whether or not the quadrat contains berries. So to recap, to randomly select the coordinates for the location of a quadrat in the plot of land, we have to randomly find an x column and a y row between 1 and 20. To do this, we can simply use two 20-sided dice. Also, to be sure to have at least 25 quadrats with berries, we'll draw up a list of 50 quadrats before leaving. But what will we do with the quadrats that contain no berries? It will be very important to check off on the label the actual state of a quadrat visited. And why so? Well, that's exactly what we are going to talk about in the next clip.